Hello Internet! Today I have an EVGA 3060 that came all the way from Puerto Rico. Did I say that right? Anyway, customer stated card got wet and it looks like there are some signs of rust all over. Tamper-proof sticker is still there, so let's take it apart and see what's going on. And there it is. I'll continue with the disassembly for now, and I'll get back to that later. Oh, and if you guys know where these came from, let me know in the comment section below. Okay, let's have a closer look and evaluate the extent of the damage. Some corrosion on some of the output ports. The most important one is the standard HDMI output, and its pins are looking good. Moving on, fuse looks corroded, possibly blown, so let's double check. Yep, it is blown. On the back side there's a hot spot. I think it's those MOSFETs that were not cooled properly. We will address this later if possible. Looks like some corrosion here, and a lot more down there. Hopefully traces and contact pads are all intact. Okay, let's take some measurements. 12 volt kiloohms, 3.3 15K, volt 5K and rising. This inductor is 1.8 volt with 1K. This one is 12 volt with kiloohms. Memory 34 ohms. This is Samsung memory, so that's normal. Kiloohms on this 12 volt inductor and almost 10 ohms on PEX. So we don't have any shorts and we're good to go. One more fuse on the back seems okay as well, so let's continue. I'll be honest, I've never done this kind of work before, and my plan is to simply clean as much as I can and reflow all the components. Those that cannot establish connection with the board will be replaced if necessary. Okay. Reflow is complete. Fuse is replaced. And the serial label is damaged as expected. So let's see if we have any voltages on the card. And it looks like all we have is 12 volt coming from PCI Express, and that's it. Everything else is dead. So how do we go about troubleshooting something like that? Simple. We need to know the power-up sequence. Basically, which voltages rise in which order. 3.3 and 12 volts are coming from the PCI slot. Those are the first two main voltages. Then we need 5 volt, and then we need 1.8, etc. Since we have 3.3 and 12 volts already, next suspect on the list is 5 volt inductor here. This is the 5 volt inductor, and it's powered by this chip U5, which is MP1475 step down converter. Basically it converts 12 volt to 5 volt. According to its datasheet, this chip uses 4.5 to 16 volt as a main power source, which comes to pin number 2. So let's check and see if we have any voltage on pin number 2. .12 volt is there, and that's within specified range. For the chip to be turned on, it needs to have some voltage on the enable pin, number 6. Checking pin 6 shows no voltage, which means nothing is turning on this chip. As a result, there will be no power good signal on pin 7, so I'm not even gonna test that. Okay, so it looks like pin 6 goes to some kind of capacitor, which this board does not have. It also goes to the back of the board, to this series of resistors and capacitors. One such resistor is 0 ohms. Let's make sure we have a signal from that resistor all the way there, and looks like we do. So the resistor is not to blame. Next I'm gonna check this capacitor here and make sure it's not shorted out, and it's good. This component here is a dual NPN transistor. If I understand correctly, if voltage reaches its base, we should be able to see voltage on the collector. But in our case, there's absolutely no voltage anywhere on any of the pins. According to the board view, this resistor should have 12 volt on this end, and the other end goes to the base of the transistor. Let's check if we have 12 volts on it. What's very interesting is, the second I power the board with the probe touching this resistor, card powers up. Once I let go, card becomes as dead as before. That's very weird, and it makes me wonder, is this resistor really 30K, as the board view suggests? Let's measure it and find out. Looks like we have many mega ohms, meaning this resistor is bad. So let's replace this little guy and see if that helps. Resistor is replaced. Let's measure the 12 volt end of it, and there we have 12 volt as before, and the other end now is somewhere around just a little over half a volt. Hopefully that's enough to wake our 5 volt step down converter from deep coma, and there's only one way to find out, is to measure it. And yes, we do, which means we also have 1.8 volt PEX, memory and core. Awesome. Let's plug this card into a riser and see if we get a picture. Drivers were installed. Device manager does not report any errors, so let's power down and assemble the card. I do not recall any thermal pads under these MOSFETs here when I was disassembling the card. Maybe they were forgotten at the factory, so I will cut away excess pads from the VRM on the left and place it there. That should keep those running cool and happy. I've seen cards with missing pads before. It makes me think that everyone should open their cards and check if they have all of their pads. Otherwise you could run into some problems in the long run. Seriously, this is not cool. I expected better from EVGA. But at the very least, the board itself is very well made. Okay, I booted into Windows. I ran firmware for a few minutes already, and as you can see, temperatures were looking good. Of course, we don't forget about superposition to make sure it all smooth, and also the valley. And as of right now, the card is fixed and it's on its way back to its rightful owner. And as for you, if you learned anything out of this video, please hit that like button and subscribe for more awesome repairs, and I'll see you later. Goodbye.